In this video, we're going to discuss how to fire a projectile from a cannon towards a mouse and maintain a consistent velocity along this line, regardless of where the mouse is in our game. So the first thing we need to do is look at our distance triangle. So if we know where the location of the cannon is, it's X and Y, as well as where the mouse is, it's X and Y, we can develop all sides of this right triangle. The hypotenuse, of course, is the direct distance between the cannon and the mouse. But we can calculate that because we know the differences in the X values and the differences in the Y values. The differences in the X values are called delta X, and the distances in the Y values are called delta Y. To get the hypotenuse, all we have to do is take the square of delta X, add that to the square of delta Y, and take the square root. This is just the Pythagorean theorem. So let's compare that to our velocity triangle. So what I did is I drew a similar triangle that represented the velocities that I was looking for. So I really want the hypotenuse of my velocity to be the same, regardless of where the mouse is positioned on the screen. And so I have to break that velocity into its velocity in the X direction and the velocity in the Y direction, which is what I'm going to use to apply to my projectile's X and Y value each frame. So let's take a look at these similar triangles. They're similar because all of the angles are exactly the same. So they're both right triangles, and then this angle is the same. So if we have similar triangles and we know all the dimensions of one, we can use that to help us find the missing dimensions of the other. Let's take a look at the ratio between delta X and the hypotenuse. I drew that in the form of a fraction, so delta X over hypotenuse. This is going to be equivalent to the ratio of the velocity in the X direction and then the velocity, which is the hypotenuse of the velocity triangle. Now that I have this equality of fractions, I can solve for the value that I'm missing, in this case, the velocity of X. So I know that the velocity of X is simply delta X times the velocity hypotenuse divided by the hypotenuse of the distance triangle. Now I know exactly how much of the velocity to apply in the X direction. I can calculate a similar equation for the velocity in the Y direction. So using simple geometry, you can calculate the velocity in the X direction and the velocity in the Y direction so that your projectile has a consistent velocity whenever it's fired in the direction of the mouse. Good luck.